So, I'm guessing we won't know this. If we have a two-variable equation, how many solutions does this thing have?
Two.
No.
A lot. Infinite. Three.
Infinite. For example, remember how we did this when we were graphing? X could be 1, 2, 3. If I plug those values in, you get a bunch. Is there any limit to how many x's I can plug in? No. So these solutions like 1, 1, 2, 3, 3, 5, the solutions are two different values. If you write them in ordered pairs, it looks like this, and you can graph them. But there's infinite solutions to this equation. If I plug in 1, 1 for x and y, it works. If I plug in 2, 3, it works. Okay, when we graphed it, how did we graph this? Well, we could do these dots, but normally how did we graph these? We start down 1 on the y-axis, and then where did we go from there? Rise 2, run 1. You guys remember? Did it all fall out of your brain? Okay. Now notice these points 1, 1, 2, 3, 3, 5. They're all in the graph. 3, 5's there. I kind of missed it, but anyway, all these points on this line, the ones I drew and the ones I didn't, are solutions to this equation, right? Infinite solutions. Infinite solutions. Now, if I do another equation, let's say y equals negative x plus 4, how many solutions is this equation going to have? Infinite. Anytime you have two variables, basically infinite solutions. Plus 4, so I'm going to start up 4 on the graph. 1, 2, 3, 4. Where am I going to go from here?
Down 1 over 1.
Rise negative 1, run 1. Rise 1, negative 1, run 1. So like that. Let me change this to a 3. So I want this to work out nicely. So I just need to lower it 1. No, that doesn't work either. I'll change it to a 2. Keep moving it. Okay, down 1 over 1, down 1 over 1. So it looks like that. Okay, now what we're doing in this chapter is how many solutions do these two both have in common?
Infinite.
No. There is one. How do you know there is one solution there? Okay, this one point of intersection represents a solution that works in this equation and this equation. Okay. So what is this one solution? In this case, it's 1, 1. Okay, does 1, 1 work in both of these? 2 times 1 minus 1 is 1. Negative 1 times 1 plus 2 is 1. Yeah, so 1, 1 is a solution in both. If you plug them in for x and y, you get an equation that works. Okay, and this is kind of what we're doing today. So it's not really new. If you struggled with graphing lines, I guess it still might be an issue, but we're just graphing the two lines. We're saying where the two intersect at. How can I check my answer? If you plug them in both and they work, you got the right answer. Okay? Graphing is the least efficient way of solving this. It's called when you have more than one equation together, it's called a system of equations. So you could technically have 3 or 4 equations or whatever. We're not going to have more than 2 equations in Algebra 1. So the 2 equations together normally should have one answer. Can you guys think of an example where they would not have one answer?
Parabola.
Okay, well, we're only doing lines. Okay, if you had 2 lines that when you graphed them they were parallel, do they have any intersection points? No. So it is possible to have no solution. You guys remember the no solution symbol? Where they never cross. How can you tell they'll never cross?
Parallel.
If they have the same slope. They're going to be parallel, yes. Whoops. Anyway. Let's see. Another case, I can't remember if they do this on this assignment. It could be that sometimes like x plus y equals 3 and like 2x plus 2y equals 6. These happen to be like the exact same line. So if you try to draw them, they would just be, they would just be on top of each other. So what we're going to put for this one, you can kind of tell because this times 2 equals this, so they're like actually the same equation. For this, I think it'll probably happen today. I can't remember if we're just going to put infinite solutions. Because every point on this line, on these lines, is a solution in both equations. Our book does not write the answer like that in this weird case, but this is how we're going to write it, infinite solutions. And then if the lines don't cross at all, it's no solution. Okay. All right. Josiah, this is where the assignment is. So on the top of your page, just write your name and the assignment. And we are going to do the odds together. And then you guys are going to go back and do the evens. The odds are also in the back, although that probably won't help you at this point. Pretty much all math books put the odds in the back. It's because math is kind of hard for a lot of people, so they're trying to help you make sure you're doing it right. That's why, but I'm just going to do them with you. Okay, number 1, we don't have to graph until number 15. So if you want to put it all on graph paper, that'd probably be better. But if you want to do them separately, you have to staple it. So on number 1, it says identify the solution to the system. So they graphed it for us. We just have to say what is the solution that works for both equations, for both lines. Does anybody want to kick us off here? No, nobody knows what's going on yet. Everybody shy.
I'm just so glad to be back in math, you know?
Yeah, I understand. Okay. Case. On number 1, where do those 2 lines intersect at?
Okay, I gotta count here. 1, 5.
1, 5. So that would be 1 to the right and 5 up. Remember, you move right or left first. So it's like a number line. You move 1 to the right and 5 up. So number 1 is 1, 5.
What does it mean if the solution is a line?
Oh, that's the infinite solutions thing. Okay, number 3, Brooke. What's the common solution on number 3? Is that a real sneeze? 3, 1, no. Was that just a guess?
Huh?
Is that a guess? I don't know where you got 3, 1 from. Okay. So yeah, this is the parallel lines thing. If they don't intersect at all, there is no common solution, and we're just going to write no solution. You can write the word no solution, or you could write the symbol for no solution. Okay, number 4, this isn't even, but since it's weird, let's go ahead and talk about it. Can you guys tell what's going on in number 4?
They're the same one.
There's 2 lines on top of each other. The book just writes the equation of the line because all the solutions are solutions to that equation. I'm just going to have you guys write infinite solutions because they have all their solutions in common. You guys know why we can't write all real numbers?
Because it's not all.
Okay, because the solutions are like 1, 3, 2, 5. The solutions are 2 different numbers. And not every solution works. Like, for example, 0, 4 might not work. But there can be an infinite solutions with also an infinite number of non-solutions. Anyways, so you can't just put all real numbers because there's 2 different numbers that make up the answer. Okay, number 5. Determine whether negative 2, 5 is a solution to the system. What do you guys think that means? Right. Plug in -2 and 5. We've kind of done this before, but we haven't done it
Yes.
in this context before. You plug in -2 for x, 5 for y, and you see if it works. So this is a yes or no question. Does it have to work in just one of them, or does it have to work in both of them? Both of them. So we have to make sure, if it's a yes in both, then the answer is yes. If it fails in one of them, at least one of them, then it's going to be no. It's not a common solution. Okay, so on number 5, x plus y equals 3. If I plug in -2 and 5 for x and y, is that a true statement? Does -2 plus 5 equal 3? Yes, it does. And then for 2x plus y equals 1 is the other equation. So if I plug in -2 and 5 into that, is that true? 2 times -2 is -4 plus 5 is 1. Yes, that does work. So it worked in both of them. So all we have to do is put yes, it is a solution. Where should we go? 7. It's x minus y equals 7 and 2x plus 3y equals 4. And we're plugging in -2, 5 still. Does it work in the first one? -2 minus 5. Does that equal 7?
Nope.
No, that equals -7 actually. So if the first one fails, you don't really have to check the second one. Because it's got to work in both. You're right. Number 9, this is actually kind of the same thing. They're just changing what you plug in each time. I don't know if I want to do all these odds with you or not. 14 is kind of weird. Do I want to do it? I'll just do one more. I'll let you guys do the odds on this section. I'll do number 9 then. X plus 3y equals 13. 6x plus y equals 7. Okay, so 2 -5. So what we're plugging in is going to change on each problem. On number 9 it says we're supposed to plug in 2 -5 and see if it works or not. Is this a common solution? So it's the same thing. So if I plug in 2 for x and -5 for y, does that work? 3 times -5 is -15 plus 2, or 2 plus -15 is -13, not 13. So number 9, it fails on the first one, so it's going to be a no again. Let's go ahead and jump to 14 though, because it's a little bit different. Y equals -2, y equals 4x. And we're supposed to plug in -2, -8. Well, let's start with the more obvious one. Does it work on this equation if I plug in -2 for x and -8 for y? Is that a true statement? Yeah. 4 times -2 does equal -8. Works on that one. What about this one though? Y equals -2. Anybody have an idea? Got a couple no's. Okay, if I try to plug in the y, there's nowhere to plug in the x. It would say -8 equals -2. True or false? False. Basically, this only works if the y value is -2. So, yeah, that's a fail. Okay, 15. Here's where we do it ourselves. Let me get me a piece of graph paper here. Okay, 15 is where we have to start graphing. Josiah, you do need to go ahead and do all the odds, even though I'm doing it. Make sure try and take good notes on the odds. That goes for all of you. That way, especially if it's confusing, so you can have something to look at when you do the evens. By good notes, I mean show like some clean work. So number 15, y equals negative x plus 5. And y equals x minus 1. Josiah, I'm guessing you've graphed lines already. Okay. Where are we going to start this top equation at? Y equals negative x plus 5. Where are we going to start at? Up 5. 1, 2, 3, 4, 5. Where are we going to go from there?
Down 1.
Down 1. Right 1. Okay. It's kind of important that you make your lines straight on this because your answer is going to be where they cross at. Kind of screwed up there, but it's okay. Alright. We're going to start this one at down 1. And where are we going to go from there? Up 1, right 1. Rise over run. Okay, is that it? No, what do I need to do now? The question is solve the system by graphing. So the answer is not the graph actually. I'm going to grade on the graph though. So, but the answer is what is the solution that works in both of these equations? So what's the common solution?
3, 2.
3, 2. Just like number 1. 3, 2. So this is the actual answer. The graphing is just the work to help you find the answer. And we're going to get this. These are going to be worth a lot. I'm going to give you like 1 point for each line and then half a point for the answer. So don't skip them. Number 17. All right, y equals 1. Owen, where am I going to start that top equation at?
Up 7.
Up 7. So if you're starting up 7, you might want to put your x-axis low. That will help you get up to 7 easier. 1, 2, 3, 4, 5, 6, 7. And then where am I going to go from there?
Down 6, right 1.
Right, negative 6 is the same thing as negative 6 over 1. So we're going to rise negative 6, we're going to run 1. Rise negative 6, run 1. Okay, I could do a third dot, but it's not going to really matter on this one. The answer is, normally I have you guys do 3 dots, right? And you can do that, but the answer is where the lines cross. 3 dots might help you draw a straighter line. Okay, Owen, do you remember how we graphed y equals 1?
It's going through the y, so it's going horizontal.
Horizontal, like the horizon, sun sets over the horizon?
It's just at the 1 and then
Okay, yeah.
a horizontal.
Yeah, you go up to 1 on the y-axis and draw a horizontal line through there. Can't draw straight lines, I'm rusty.
It's been a long break.
Okay, so what is the common solution?
1, 1.
1, 1. Don't forget that part. Okay, 19. What's different about 19? Why are these in the B section? It's in standard form instead of slope-intercept form. Slope-intercept form is the useful form for graphing. Let's see, 18. Miranda, do you remember how we change it into slope-intercept form? Okay, we want it to say y equals blah, blah, blah. So how do I get y by itself on this side of the equals? How do I get rid of this guy? Yeah, minus 4x, minus 4x. So that goes away. And over here, what do I do with 7 minus 4x? Nothing really. You just, but we do change the order. Negative 4x, and that's a positive 7, so that's like a plus 7. Okay, now it's ready to graph. And, okay, Miranda, what should I do on the second one? Start with the x. Yep. Subtract away. Yeah, the x, if this was like a 5 right here, how do we get rid of the 5? How do we get rid of a value of 5? You just take it away, right? So it's an x, so to get rid of it, we just take away x. So that goes away, so we're going to subtract x over there. Negative 3y is left on the left side. Over here we have 18 minus x. Do those mix? No, they do not. But also I'm going to put minus x in front of plus 18. Some people might put like minus 18x. Why is that wrong?
This is not multiple.
That means multiply, and these are not multiplied. So anyways. Miranda, how do I get rid of this negative 3? Yes. And when we divide, it's kind of like distributive property. Everything gets divided like that. So the negative 3 over here goes away. What's this middle term going to turn into? Invisible 1. Negative 1 divided by negative 3 is positive 1/3 x. 18 divided by negative 3 is negative 6, plus negative 6 is like minus 6. Yeah. I do have your finals. Did they already email out your guys' grade cards? I did curve it some because the finals usually pretty hard because you have to, try to remember everything. Some of you actually brought your grade up. I'm sure you guys know who you are. Did somebody bring their grade down? I don't remember, to be honest. Who knows? Let's see. Moses, where am I going to start this graph at? This is very tall because we're going from plus 7 to minus 6. I don't know if I made my line long enough. Yeah, let's do this. One, two, three, four, 5. 1, 2, 3, 4, 5, 6, 7. Yeah, fits, I guess. So we're starting up 7, and then we're going down 4, right 1. Down 4, right 1. Okay. Kind of missed there. That's all right. All right, and then where am I going to start this graph at? Down 6, 1, 2, 3, 4, 5, 6. Well, I think like what I did on the final was I took a couple problems off as like basically made them bonus. I felt bad about like 2 of them. But there was, I think 3 of them I didn't review the week before the final, so I was like, yeah, we'll give them a few freebies there. Like the exponents, like I think there's something like this. We didn't review that, I don't believe. So anyways, so I gave you guys a few freebies. If you got it right, I gave you credit for it, but okay. Anyways, the slope is 1/3. So that means we're gonna go up 1 and over 3. I kind of missed my dot there. So what is the common solution? Alright, it's 1, 2, 3. And we're going down 1, 2, 3, 4, 5. So 3 to the right and 5 down. 3, -5. How could I check this if I wanted to? If you plug it in and it works in both. You could plug it in the original standard form or you can plug it in the new one. Okay, last one, 21. X plus 2y equals 10. And 9x plus 2y equals -6. Alright. Moses, what should I do on this first one?
You change it into the
Slope intercept. So what should I do?
you subtract x and then divide everything by 2.
Yeah, trying to get y by itself. Okay, negative x, that's like a -1, so it becomes -1/2, or -1/2. 10 divided by 2 is 5. And down here, kind of repeat that process, subtract 9x. Okay, 9 divided by 2 doesn't really work, so I just left it as an improper fraction, 9/2. All right, this one goes not as tall as the last one. But on this first equation, this one right here, I'm going to start up 5. So 1, 2, 3, 4, 5. And then where am I going to go from there? -1/2. Down 1 right 2. Okay. Okay, and then this graph I'm going to start at -3 on the y-axis. Alright, well, this says -9/2, so that's either down 9 right 2, which will be way off my graph, or what else could I do?
Go up 9, back 2.
Right, you can go opposite. Up 9, left 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. What a coincidence, they cross right there. Now, this only works if your answers are nice and neat and they meet like perfectly. This method does not work if you have like messy fraction decimal answers. But we're going to learn another method tomorrow that works all the time. We actually have 2 more methods to learn, and neither of them are graphing. This is the last graphing thing for a while. Anyway, where are they meeting at? -2, 1, 2, 3, 4, 5, 6. -2, 6. I would like to check, maybe I'll check number 2 and then hopefully 16 if everybody gets there.